Hello and good afternoon, CSI258 Section 847 students for the second 8-week term in the spring 2015 semester at Anne Arundel Community College. This afternoon's Packet Tracer tutorial is going to be on Packet Tracer Activity 9.2.3.12, and this is an outstanding activity that's going to allow you to use your skills that you've learned throughout the course to do some troubleshooting. So let's hop in here. You can see we've got our addressing table over to the right that we're going to be referring to often. We have the background, so we're going to use a variety of technologies that we've learned so far. VLAN, spanning tree protocol routing, inter VLAN routing, DHCP, NAT, PPP, and frame relay. So we're going to review the requirements and then isolate and resolve the issues. So if I scroll all the way down here, you'll notice that we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 boxes where we could have, or where we could list out issues. And I don't think it's any coincidence that we've got 3 topics under VLANs and access, 3 under routing, and 3 under WAN technologies. And so we're just going to work our way down this list because I'm pretty certain that there's probably going to be a very close correlation between the problems we need to solve and basically these statements that we see here at the top. So let's go ahead and jump in here. So it says switch 2 is the spanning tree route for VLAN 11020, and switch tree is the VLAN spanning tree route for VLAN 30 and 88. So let's start with switch 2 here. As you can see, we've got a couple ports in the blocking state on switch 2. So I'll bring it right out to there. So immediately, and we haven't even typed anything in yet, you can see that we have a native VLAN mismatch. So if we take a look at this message, it says discovered on Fast Ethernet 03, and on Fast Ethernet 03, the native VLAN is 99. And it says with switch 1 Fast Ethernet 03 and switch 1's native VLAN is 1. So just looking at this leads us to believe that if we go back to the addressing table, you can see here the trunk links connecting the switches are in native VLAN 99. So right away, switch 1 is going to have probably no switch port trunk VLAN native or native VLAN 99 statement on the port. So we'll come back to that. Let's go ahead and roll down here. And so on switch 2, what we wanted to look at was we're going to check, oops, sorry about that. We're going to check some spanning tree stats, right? So let's go ahead and do a quick show run. And using our troubleshooting methodology, we're going to be looking for any kind of spanning tree configuration. And what we have is just the spanning tree mode, which is per VLAN spanning tree, or the IEEE mode, right? So the mode is the IEEE, and we're running per VLAN spanning tree, which is Cisco's version of, they took the standard and put their special sauce into it, and we ended up with PVST. And remember that with 802.1q, it's PVST plus, right? So, but it's got the mode here, and if I were to say show spanning tree summary, I believe it is. If we scroll up, yeah, the mode is PVST, and protocols IEEE. Mode is PVST, protocols IEEE. If I were to say show spanning tree, you can see here protocol is IEEE because it's referring to the legacy IEEE compatible spanning tree protocol that Cisco took and modified. So, but we don't see anything indicating that those VLANs that we should be the root for here on switch 2 are actually set up. So let's go ahead and do that. So we're going to say spanning tree VLAN 1, 10, and 20 and root primary, right? So we should be the root for those VLANs. Now if I say do show run, you can see we actually have the statement in there now, the spanning tree VLAN 1, 1, 10, 20, priority 24, 5, 7, 6. We went ahead and used the macro, and we are now the root for those VLANs. So if I say do show spanning tree root, and let me see, is that command not here? Show spanning tree. We don't have root. Okay, so we'll just go ahead and say show spanning tree. We should be listed as the root. So this bridge is the root. For VLAN 1, for VLAN 10 we are the root. What about for 20? This bridge is the root for 20. What about 30? We are not, and we're going to get rid of this output here, these error messages that are being logged to the console. So for VLAN 30, we are not the root bridge. However, that is the MAC address of the bridge that is root. All right. So we've taken care of the spanning, or I'm sorry, not the spanning tree problem. We've taken care of the root configuration on switch 2. Now let's go ahead, let's go over to switch 1, and let's get those messages to stop. Again, I'm assuming that when we take a look at switch 1, we're going to see that it does not have, and is it logging between switch 3 and switch 2. So you can see here switch 1 has the issue because it's logging the error messages between switch 1 and switch 3 and switch 2. And it's showing that it is VLAN 1 for its native VLAN. So let's go ahead and do a show run, and there you go. So fast Ethernet 01, 02, 03, and 04, they are in the right mode. They are trunk ports. However, none of them are properly configured. So let's go ahead and go into global config, and we'll say interface range FA0124, and we're going to say switch port trunk native VLAN 99. And that should resolve our issue, any issues that we have there with the log messages that we've been receiving. So let's now go ahead and do a do show run. Right, you can see the native VLAN statement is in there. Do show interface trunk. What do we have? So we've got our native VLANs properly set. I actually could have run this initially, but was going on a hunch that that was what it was based off those error messages. All right, so it looks like we've taken care of that. So now it says router 3 is responsible for inner VLAN routing and serves as the DHCP server. Now this is under VLANs and access, right? So there's a good possibility, and let's check here on PC1. Let's just take a look here. Is it getting a good DHCP address, or is it getting an APIPA address? And it looks like it's going to get an APIPA address. Let's go back to static here, and let's flip it back to DHCP. Let's give it an opportunity. Let's see if it's going to pick up the right address or go back to APIPA. And as you can see here, it went right back to APIPA. So something is wrong. And if this is our DHCP server, and this is the link across to the VLANs, let's take a look at router 3. And let's take a look at specifically the configuration settings that exist on interface gig 01. So let's do a show run, and right away you can see we've got some DHCP information that's listed out here for us. So let's take a look at the excludes and make sure that we're not excluding too much. So for the 192.168.10.20 and .30, the first 10 addresses have been reserved, and so those statements all look okay, no issues there. So now let's look at our pool. Is there anything wrong with our pool, or the pools? So network 192.10, 192.168.10, class C, right, or /24 I should say, so we're good there. Default router's correct. The pool for VLAN 20 is the right subnet, right mask, right default router. We've got VLAN 30, right subnet, right net mask, and correct default router. So that actually looks good, surprisingly. I was anticipating that something was going to be wrong in there. And now let's go down and take a look at the interface, and let's check all of the sub interfaces that have been configured. So as you can see here, gig 01, and this is interesting. Actually, did it say? It certainly did. So there is a very big mistake here. However, and I don't have, let's get desk scribble up. Where's desk scribble at? And we'll let desk scribble start up here. And I'm going to shrink the font because I know that the font goes rather large right away. And let's take this, let's drag this down as far as we can go. There we go. All right. So as we look, right, you can see it's gig 00.10, gig 00.00.00. However, when we look over here, it's 01 and it's actually configured on 01. So it looks as if this, the addressing table, is wrong, that this should be gig 01.10, 01.20. And in a troubleshooting exercise, this is kind of a catastrophic mistake here on the packet tracer side, where that definitely should be correct, because that makes it just that much more difficult when you're looking at this thinking, well, what if I change it to 00? Well, how could we do that? How could we deal with this to double check to make sure that it is gig 01? Well, let's go into global config mode. Let's go into gig 01 and let's type shut. So as you can see, it is clearly gig 01 that is being used, right? And I'll say no shut, bring it back up. And we're going to go ahead and let the spanning tree run its course on the gig 01 port on switch 3. We're going to go back into our show run. And so let's take a look at our sub interfaces. So the addressing table, again, the addressing table is wrong. These are the wrong sub interfaces in the addressing table. And that is not one of the requirements of things we should find that are wrong, because there's no way for us to actually correct that. So this looks good, right? Incap.1Q10. We've got the right IP address, right subnet mask. Same thing with .20, .30, .88 is correct. So surprisingly, it looks like the configuration on router 3 from a DHCP perspective is correct. So if that's true, the only other problem that we could run into is probably something on switch 3. Specifically, is that port set up as a trunk port? And it's going to be gig 01. And you can see we do know it's gig 01 on switch 3 because we just shut the interface down on the router and this alerted, right? Switch 3 logged a from what facility, right? The line protocol and notification severity level, and then our mnemonic. Interface went up, down, and then a description, right? Remember that from chapter 9. I'm sorry, from chapter, yeah, that was right, chapter 9. Okay, so let's go into privilege exec from user exec, and then we're going to go into, we'll just actually do show run here, and we'll go down. We're looking at gig 01. All right, so anything you see here that looks a little suspicious on gig 01. So switch port trunk native VLAN 99, that's actually correct because the native VLAN is 99. However, if I do a show interfaces trunk, does gig 01 show up here? It does not. And why do you think that is? Let's go back down. Right? What if I were to say show interface gig 01? Do we see anything here? No. What about what's the command I'm thinking of? I'm drawing a blank here. I'm drawing a blank right now. Show interface switch port. Sorry, there we go. Show interface of switch port gig 01. Show interface switch port. It's not going to allow me to specify the specific port. I'm going to have to look at all of them here. Let's fly down. All right, so here's gig 01, right? So the switch port is enabled. The administrative mode is dynamic auto, but what is the operational mode? Well, currently it's an access port, right? We need it to be a trunk port. So let's make the change, and we're going to come back and take a look at this and see what it looks like after the fact. So we're going to go into global config and say interface gig 01, and I'm going to say switch port mode trunk. Alright, so spanning tree is going to do its thing, but that's okay. It gives us time to run the checks that we need to run. And let's go back down here. Let's see if it left the native VLAN statement on there. It did. So fantastic there. And now let's say do show interface trunk. So we should have a new member here, right? Because this is a trunk port now. Our in cap is .1Q. The native VLAN is correct. And so finally, let's say do show interface switch port. And we'll have to go all the way down here to the bottom again. See if I can catch it. So there we go. So now, what does our operational mode show? So when I do the do show interface switch port, oh, you know what it was? I'm sorry. Do show interface gig 01 switch port. Sorry about that. There we go. I knew there was a way to trim that down so that we only saw the interface we were interested in. So the operational mode is trunk, right? So it's no longer a static access port, it is a trunk port, and that's what we need. And so now spanning trees reconverged. Let's take a look at PC1, and this is perfect. All right, take a look at that. So we've picked up our DHCP address, we've got our subnet mask, our default gateway. How about PC2? Perfect. And you'll notice we're picking the first IP address up outside of the excluded range. What about PC3? Fantastic. All right. So the DHCP piece seems to be taken care of here. So these three tasks right here appear to have all been done, even though it's 20. I guess that is a third, so that they may be doing it like that. So we may have to come back, take a look. Maybe we missed something, or maybe there's something else, another issue that needs to be resolved somewhere. But everything looks good right now. So now let's come down. It says each router is configured with EIGRP and uses AS22. So let's go ahead and take a look at the EIGRP configuration. We'll say do show run. So on router 3, let's take a look here. So it's got passive interface gig 01, and we would anticipate that, right? Because this is facing our LAN segment. We've got a network statement for 10.220. It's a /20, or I'm sorry, /30. And for 10.330, and that's a /30. And this actually looks correct. Now, auto summary. So we're going to turn off auto summary. So we'll say, oh, we're in global config, sorry. So we'll say router EIGRP 22, and I'm going to say no auto summary. Let's do a do show run again here. And there we go. All right, so no points for that, but we want to make sure auto summary is off. Other than that, the EIGRP here looks good. Let's take a look at router 1 and make sure that it is in the correct AS. So we'll go to privilege exec, and I'll say show run. And this should only have 2 statements. It does. It also has, whoops, auto summary on, so no auto summary. Sorry about that. We'll get into the router EIGRP 22. No auto summary. And let's take a look at it one more time here. So the 10.1.1, the 10.3.3 for the segment between 1 and 2, let's confirm that. So router 1 should be 10.1.1/30, 10.3.3/30, and that is it. So it looks correct there. All right, I'm anticipating there's got to be an EIGRP issue here somewhere. So now let's take a look at router 2, where there is a lot going on. So we'll go to privilege exec, and we'll say show run. And let's come down and look at the EIGRP setup. So we've got 10.1.1. This is between router 1 and 2, and that is correct, /30. The 10.2.2 between router 2 and 3, and that is correct. We've got the redistribute static statement, that's correct, and then we also have the network statement for the TFTP server LAN segment here. So at first blush, the EIGRP router configuration sections look complete. So let's move on. The AS is correct. Let's go ahead. We'll jump to this next one here and continue to work down. So R2 is configured with a default route pointing to the ISP, and it redistributes that route. So here is the statement we need, which is redistribute static. Let's look at this default route. So IP route quad zeros gig 00 and no. So as you see here, the actual default route statement is pointing to the gig 00 interface, which pushes the traffic to the TFTP server LAN, the internal LAN here, where we want it to go out the gig 01 interface out to the ISP. So let's go into global config and we'll take care of this right now. So we'll say no IP route, copy and paste. And then we'll say IP, well actually we can make it a little easier here. And then Control A. Alright, so we want IP route quad zeros to gig 01. And we're actually going to go check this. Let's check on router 3 and say do show IP route. So we should have an external because it's being redistributed, EIGRP default route. And on router 3 it says go out serial 001. Right? What about router 1? If I were to say do show IP route, we should also, and this is probably tied into the frame relay cloud setup here because, yeah, there's all kinds of stuff going on between these routers. So this may or may not be related to EIGRP. It probably is related to something going on here is my guess. But on router 3, we were able to confirm that it is being redistributed. Once we get connectivity sorted out here, we'll be in a better situation. All right. So default route. So we took care of the default route. So it says NAT is configured on router 2. No untranslated addresses are permitted to cross the internet. So let's take a look. And what are you thinking for the NAT, right? So what could be wrong? The access list could be wrong. The IP NAT inside statement tying the access list to the pool or to the interface could be wrong. What else could go wrong? Our IP NAT inside outside statements could be wrong, so we need to take a good close look at those. So looking at router 2, gig 00 and serial 000 and serial 001 should all have IP NAT inside. And so as we roll up here on gig 00 right out of the gate, you can see it says IP NAT outside. So let's knock this out, gig 00, say no IP NAT outside, IP NAT inside. And then we'll do a do show run and continue on. So we should have on the serial interfaces also IP NAT inside, and you can see we have it on both of those interfaces. All right, so let's continue down to our statement here. So IP NAT inside source list NAT. So there's got to be a standard access list that we're using here, named standard access list with the name of NAT, and we're actually doing dynamic NAT, or I'm sorry, we're actually doing NAT overload, which is referred to as PAT, right? Port address translation. And we're referring to the interface as opposed to a pool of addresses. And the reason for this, it mentioned it up here earlier, that we are picking up via DHCP the address from the ISP. And so this is actually a very interesting use case. If you're getting your IP address from DHCP on your outside ISP facing interface, you would definitely want this statement here. You would want to identify the interface and not the IP. The reason being is that for whatever reason, if you were to have that DHCP address change on you and you had all your NAT statements tied to that IP address as opposed to the interface, as soon as that DHCP address that the ISP is providing you changes, you're done. Your NAT's broken at that point, right? So by referring to the interface here, the router is always going to be able to figure out what the IP address is. It just will look to see what is the current IP on this interface. That's what it's going to use. And the overload keyword, remember, that is the single configuration difference on this statement right here between dynamic NAT and NAT overload, right? Or PAT, okay? And so this statement actually looks good. I was assuming that there may be something funky. So maybe it's the access list. Let's take a look at our access list here. So IP access list standard NAT. So that's the access list we're using. Is there anything wrong here? So 192.168.0.0, that's correct. Our 10 dot statement is also correct. And then of course, they're going to throw in here an access list with the name of private that is not being used. I would have anticipated, had I had to bet on it, I would have said that they would have had private here and then, you know, made you go in and make the change there, but that's not the case. So that actually looks correct. So from what I see, it appears that those are the only two issues, or I'm sorry, those are the only issues. The IPNAT inside and outside statements were the only thing wrong. And that has me scratching my head, because typically you'll see it'll be a little more difficult to track the problem down. Okay, no, NAT. All right, so everything looks good with the NAT. So let's jump into the serial links here. So because there's got to be an issue between these guys of some kind, and between these guys, right? Because router 1 is seeing nothing in terms of the EIGRP config. So the serial link between router 1 and router 2 uses frame relay. So let's say do show run. Let's look at serial 000, in cap frame relay, so it's good there. Let's take a look at router 1. Do show run. Serial 000, and let's double check that. Yeah, so it's set up for PPP. We know that that is not correct. So let's make that change. So no PPP authentication chap, and I'm going to say no in-cap PPP, and we're going to say in-cap frame relay. So we should have interface go up. I'm hoping that we've got an adjacency that forms here with EIGRP, unless there is an additional issue. So let's say do show IP route now. If we've picked anything up, no, just the local settings. So let's see here, do show, oh, there we go. Was not being patient enough. So do show IP route. All right, now that looks much, much better. Let's see, can I ping from router 1 out to 209.165.201.10? Do ping to, oh, I'm sorry. And yes, that is not a valid IP address. So 209.165.201.10. We've got a couple failures here. All right, so we cannot get out yet from router 1. So let's go ahead and continue our troubleshooting here. And let's take a look. So the serial link between R2 and R3 uses HDLC. So let's come back over here. So how can we tell it uses HDLC? It's if there's no encapsulation in the show run output, or if I said do show interface serial 001, you can see right here, it shows me my encapsulation is HDLC, right? So router 2 looks good. Let's check router 3. So do show interface serial 001, and one too many forward slashes there. All right, what is my NCAP? NCAP is HDLC, so it looks good between router 2 and 3. Now let's take a look at the serial link between router 1 and router 3. That should be using PPP. Do show run. So there is the link. It's serial 001. So the NCAP is PPP. The PPP authentication is CHAP. So that means we should also have a statement here, a username statement, and it says CCNA password. So let's check and see. Router 3, we should have a statement for router 3, right? Because if there's a mutual challenge that's taking place, let's see what router 3 is set up with here. And router 3 does have a statement for router 1. So let's go ahead on router 1 and go to global config and type in username R3 password Cisco CCNA. See if that makes a difference in the score, and it does. All right, fantastic. So that has been taken care of. Let's see here, and that neighbor relationship is now up. So does that change anything? Can I say do ping 209.165.201.10? Can I get out of the network yet from router 1? And I still cannot. However, let's continue looking here. Do show run. Let's make sure. So it's supposed to be, pull this back up here. Encapsulation PPP, PPP authentication CHAP. So we're good there. /30. And take a look at router 3. Do show run. So the username statement is there on router 3, and there it is, and sub interfaces are good, and serial 000 and CAP PPP and PPP CHAP. Let me check the IP address, 10331 10332. So it looks good, right? So if I say do show IP EIGRP topology, and this is, again, I'm on router 3 here. We've got everything. Do show IP EIGRP neighbors. So I've got my neighbor relationships are up with router 1 and router 2. So we've got 5 points hanging out there. And my guess is it's got something to do. Let me check. So let's do this. Do show run. So on gig 00, do we have, or under, I should say, the EIGRP config, we have EIGRP configured, but should I have passive interface on here like I do here? So let's check that out. So let's say router EIGRP 22, and I'm going to go ahead and say passive interface gigabit Ethernet 00, and that does not bring us, that's not what they're looking for. So each router is configured. So this was the one where we didn't have, or I didn't see anything. Each router is configured with EIGRP and uses AS22. So we have one outstanding issue right now, and let's do a do show run again here. Let's check this out. So we've got IPNAT inside, and that's the correct IP and subnet mask. We've got our DHCP statement. We've got the in-capped frame relay statement with the IPNAT inside, and that's correct. We've got IPNAT inside, that's correct, using HDLC. We're redistributing the static. We've got the 3 network statements, and those are correct. The NAT statement is correct. The default route has been changed. That's correct. Our access list is correct. So router 1 looks good. So let's save this off here. I'm sorry, router 2. Let's jump back over to router 1, and we're going to say do show run. So we've got our R3 username statement that brought up our WAN link between 1 and 3. None of the gig interfaces are being used. So serial 000, the encapsulation's frame relay, so that's correct. /30 with the right IP. Serial 001, encap PPP, PPP auth CHAP, /30, that's correct. Router EIGRP 22. So both of those network statements, it's originating the transit networks, right? So those are correct. There's nothing else needed there. So we're good here. So we'll say write mem. Let's drop over to router 3 for a final do show run. So we've got our DHCP is correct. We saw that earlier. Username statement is correct. Let's take a look at the sub interfaces here. Make sure that those all look good. So serial 000 incap PPP auth chap, that's correct, /30. HDLC is that, let's double check that. Yeah, we're using HDLC between 2 and 3. We have our helper address for DHCP as well, because we've got to get up to router 2. Alright, what else do we have here? VLAN 1 is shut down. On router 3, passive interface gig 01, that's correct. We've got the network statements are correct. So everything looks good on router 3, unless I'm looking past something here. Right, mem. So now let's walk our way back. Everything looked good in here. Let's see, can I ping 209.165.201.10? Let's see if we can ping from our PCs. And this may be ARPing for the default gateway. And let's check and see here. So this does not look good. So I can't get out from router 1 and I can't get out from PC 3. So let's pull this back up. Let's see how far we can get. Right? So trace RT 209.165.201.10. Let's make this a little bigger. So where do I go? I make it up to 10.221. But that's it. So I get here to router 2. So let me, did I change? We have IPNAT outside correct on gig 01. I was so focused on, aha. So what do you think the problem is? So we got our IPNAT inside statements correct. However, we ran right by interface gig 01 IPNAT outside. All right, so we add the and just look at that. As soon as we typed it in, boom, it worked. So we'll put this back in here. There we go. It's working like a champ now. So if I were to say do show IPNAT statistics, you can see that we've got some translations. It shows our inside interfaces. It shows the outside interface. What if I were to say do show IPNAT translations? So here are the translations, the ICMP ping packets that were going outside. And so that wraps it up. And I apologize, I had went right by it thinking that it was on there. It was not on there. All right, so we've got 60 out of 60, and this wraps up Packet Tracer Tutorial 9.2.3.12. We've got a couple more of these to do, and these are some fantastic activities. Gives us an opportunity, again, to put all of the skills that we've learned throughout the semester to work for us and to solve some pretty complex problems at the CCNA level. All right, thanks for watching, and hopefully this has cleared up any confusion you had and helped you along your way. Have a great evening.